One of HOMED's main objectives is to develop an improved prevention knowledge base and innovative tools, allowing the rapid detection and identification of native emerging or non-native invasive forest pests and pathogens. As part of this effort, HOMED partner Milan Dvorak from the Mendel University in Brno, Czech Republic, further developed a spore trap system for sampling aerial particles called ROTTRAP 52. The system is originally designed for sampling spores of fungal pathogens, but it can be used for sampling of other airborne particles like pollen, mites, parts of insects, or algae.
Hello, my name is Milan Dvorak. I'm employed at Mendel University in Brno, Czech Republic, and I would like to introduce you this device, which story started in 1957 when Perkins developed this system for sampling aerial particles. This rotating arm spore trap, how it was called, or shortly ROTTRAP, was further developed, and the story connected with me started in 2013 when I went for a short-term scientific mission to Belgium, and with the help of Dr. Anne Chandelier, we developed it a little bit further, and finally with the help of the HOMED project we came to this final version, which seems to be rather resistant to every use with forest and other tree pathogens. The spore trap in this performance is called ROTTRAP 52, which means that it samples around 52 liters of air per minute. ROTTRAP 52 is able to collect particles of size at least 11 micrometers in diameter.
Additionally, there is another version of the ROTTRAP which has a prolonged aluminum bar of 20 centimeters, allowing it to sample 104 liters per minute and to catch smaller particles. You can choose the tool type which best fits your sampling needs.
The construction consists of this bar, which is mounted by any manner to the ground or to a tree. It also consists of this console, which is very easily fixable to this bar. On this console you can see there is mounted this box, which contains electric engine, an electric motor which rotates this aluminium bar. And this aluminium bar holds these two rods, which are actually those parts which are sampling the air. To install the ROTTRAP, you are gonna use this double-sided non-woven tape. You should choose this size because the rods have exactly 50 millimeters, which is the width of this tape. And at this moment we have to realize the direction of rotation of the ROTTRAP. Here you can see this arrow, or you can even try it by connecting it for a short time to see the mean of rotation. And this tape must be fixed to the rod to cover the impacting side of this rod. Then you take a sharp razor. The best is to use a new one every sampling. And following the rod with the razor, you cut exactly on the edge of it, so that you can get finally only the area which has the width of 0.8 millimeters and the length of 50 millimeters. So at this stage I have both impaction sites covered by the sticky tape. Now I can mount it again to the pole and we can start the sampling. The best way how to feed the electric motor in the ROTTRAP is the 220 volts. If it's accessible, it's the best way. The ROTTRAP can be with this adapter, AC-DC adapter to 9 DC volts, which ensures the proper rotation of 2067 rotations per minute, giving the described sampling rate.
Alternatively, the ROTTRAP can be connected to a 9-volt battery.
It is recommended that the sampling doesn't take longer than 48 hours, because after that time the sticky tape gets overloaded with all the particles which are present in the air, and it doesn't trap more spores.
At the end of the sampling, exposed tapes are detached from the rods, inserted directly into 2 milliliter screw cap microtubes, and stored at -20 degrees Celsius to prevent spore germination. The best way to detect and quantify the target fungal spores is to extract DNA from the tapes and perform quantitative real-time polymerase chain reaction. Alternatively, it is possible to spread the exposed tape on a microscopic slide and count the target spores manually with a biological microscope. A detailed manual on how to use ROTTRAP 52 for sampling ascospores of Hymenopsyphus fraxineus, the pathogen causing the ash dieback, has been recently published.
Thank you for your attention.